Okay, great. So hi everyone. So we have Madhav today as a first change maker with us. There'll be two more change makers who will be joining in and having the session with you. But for now, I'll let Madhav get started. I hope everyone is here. Everyone is able to hear me clearly. Great. Let's get started. Over to you, Madhav.
Okay, thank you. Hi everyone. मेरा नाम माधव है and today I will talk to you about space and this PowerPoint will cover everything you need to know about space. So इस PowerPoint में space है और universe भी है और theories, principles, laws भी है और physics as well. तो फिर cosmology क्या है, right? Cosmology is the study of the world, of the universe. Scientists जो cosmology पढ़ते हैं वो universe पढ़ते हैं और how the world started. Um, Historical progression, right? ये एक timeline है, which covers the full astrophysics in the world, right? So it's from 0 to 100. ये timeline है. This is what historical progression means, and we will be talking about many scientific principles, right? And in these scientific principles, we will talk about Big Bang, cosmic inflation, and dark energy, right? So this is what we're going to talk about in this PowerPoint. क्या किसी के पास कोई सवाल है? नहीं? ओके, तो फिर यूनिवर्स की ओरिजिन, तो फिर बिग बैंग is how the universe started, right? This is the leading explanation for the origins of the universe, right? This is how the world started. This is how everything started. Now, cosmic microwave background, ये एक radiation है, right? So if you have the sun, so if you have the sun, okay, this is sun, ये sun है और ये रेडिएशन है, ये रेडिएशन है, राइट? तो फिर ये कॉस्मिक माइक्रोवेव बैकग्राउंड, ये बस ये रेडिएशन है पर स्पेस में, दैट्स व्हाट इट मींस. और फिर expansion of space, right? ये this talks about the distance between ये galaxies, right? Distance in between these galaxies, these are increasing. This is increasing, right? तो फिर एक galaxy इधर है और इधर है, right? Over time, distance in between them increases. That's what it means. That's what all of it means, right? So then we go to the Big Bang Theory. Now, the Big Bang Theory suggests and states that universe expand हो रही है from a mysterious force. Ye force is called dark energy, right? So if universe is expanding, ye universe, right? This is the universe. ये expand हो रही है, ये continuously expand हो रही है due to this force called dark energy. बहुत ज्यादा evidence है इसके लिए and ये background बस principles की बात करते हैं. And okay, now we talk about cosmic microwave background, right? Now, this provides evidence for the Big Bang theory. So, like we talked about before, ये radiation, right? Because of this radiation, we know that the Big Bang is true, right? This proves, this is the evidence of the Big Bang. Now, this background, इसकी temperature है 2.7 Kelvin, right? Now, we know temperature is degrees Celsius or degrees Fahrenheit. एक और unit है, उसका नाम है Kelvin. Kelvin एक और unit है, right? और CMB का temperature है 2.7 Kelvin, okay? And CMB बस radiation है from the Big Bang, right? Big Bang इधर है, इसकी radiation, this is called CMB. कोई सवाल है? Any? No
Everyone
सवाल?
understood so far? Please give a thumbs up if you're understanding so far.
Okay.
Okay. Great. What about Sanya, Sakshi, Danish? Okay, there are some questions on the chat box. Do you want to answer
Chat
those?
box. Oh
Yes.
yeah, sorry.
No problem.
Remnant radiation. Okay. Sanya's asking what does remnant radiation means. Okay. Remnant radiation. This is just sorry. Remnant radiation is just ये object है, right? ये radiation, it makes radiation, it emits radiation, right? It's this radiation is being created. This is called remnant radiation. And remnant means because it's in space. If this is the sun, right, this is the sun, this is the suraj, right, it's making radiation. This is just radiation. But if there is a star in space, right, this is space outside the earth, then if it's emitting radiation, this is called remnant. Is remnant is remnant radiation is equal to only in space, right? This is only when there is space. That's what it means. Does that answer your question?
Yes, please. Thank you.
No worries. Okay. Yeah. So we were talking about this CMB. CMB is just radiation, and it's the evidence for the universe's, origin. Now we're gonna talk about the expansion of this universe. Now, एक scientist था, उसका नाम था Hubble, right? और this law, Hubble's law, states that ये galaxies वो expand हो रही हैं, right? Because these galaxies are expanding, this means universe is also expanding. This is the Hubble's law. That's what he's saying. If universe is here, after 3 seconds, it's going to be here. After 10 minutes, it's going to be here. It's expanding. And this is continuously happening, right? And ये dark energy, ये mysterious force है, right? The because this is causing these galaxies to move forward, right? If the galaxy is here and it's going here, this force is called dark energy. This is what dark energy is, right? This is the force, dark energy. It's just a mysterious force. Now, this cosmic background radiation is the afterglow of the Big Bang, right? As you can see here, this is what the cosmic radiation looks like. This is the glow of the Big Bang. When the Big Bang started, the radiation which is being emitted, right? It is in different colors, and these are the colors here. So this is just the afterglow means it's showing the universe's origin. Does anyone have any questions? No? Maybe in the chat box you can add a question if you want. Okay. Yeah. So then we're gonna move on to dark matter, right? What is dark matter? Dark matter क्या होता है? Right? ये एक unseen form है of a matter जो light नहीं emit करता, right? So sun है, right? ये light create करता है. पर dark matter एक sun भी है, पर light नहीं emit करता. ये dark matter है. You can't you can't see dark matter. There is no light. It's just black. You can't see it. It's invisible. It exerts gravitational forces, right? ये dark matter है और ये forces create करता है gravitational, right, which forces objects to move. ये move objects को move करता है. बहुत ज्यादा theory हैं. um, ये theory हैं विम्प्स और एक्सियन. ये बस theory हैं dark matter के लिए कि कौन सी direction में push करते हैं और size और वो सब. पर yeah, वो theory हैं. Okay, dark energy, right? Now, dark energy means the universe is expanding at an accelerating rate, right? Now, Einstein's cosmological constant, ये बस एक framework है, right? ये एक number है, एक letter, एक number, right? ये एक number है which shows the speed of this acceleration, which shows how much it's accelerating, right? If this is the universe, this is expanding here, right? It's getting bigger. The speed of which it is getting bigger is called this. This is the constant. Now we have the observational evidence. There is something in space called supernovae and CMB, right? Supernovae is just a colorful cloud. This is what supernovae is, right? It's a colorful cloud. ये रेडिएशन क्रिएट करते हैं और ये रेडिएशन proves dark energy is real. This is what it means. Now, Einstein, does anyone have any questions? Any questions? Just raise your hand or you can put in the chat box. No questions?
There is a question in chat box.
How can scientists investigate this invisible force? Okay, good question. So, sorry, let me just get my, yeah. So, dark matter, the invisible force. Okay. So, you see this dark matter here? The reason it knows about this force is because in space, this emits radiation. This, let's say you have a, like the sun here, right? If the sun is moving till here, what is causing it to move, right? Now scientists know that it has to be dark matter. These gravitational forces, yeah, these move these objects. So they know these, they investigate these forces by looking at the movement of different objects. That's how it's caused and investigated. Does that make sense?
Yes, please. Thank you.
No problem. Okay, yeah, so yeah, any questions about dark energy, about the constant, the expansion, evidence, anything? No questions? Okay. Yeah. So we're gonna move on. Oh, yeah, Tapsi.
Yes, please. Actually, I have a question. I put it
Yeah,
on chat, please.
chat. Okay. Uh, what is dark matter's impact on the universe? So dark matter, all it does is it pushes objects. It doesn't really affect us because matter is very far away. It's outside the solar system. But on the universe, it just moves objects. That's all it does. It has no other purpose. Dark energy is much more important because it's showing that the universe is expanding. But dark matter is just pushing objects. It's just forces. That's it. There's no much impact. Yeah,
Okay.
Durgeshwari and Madhuri.
Yes. So my question is, this expansion of universe, is there any limit? Have scientists been able to find that? Is there any limit of expansion of universe, or it's like limited, restricted to certain things? Is it like that?
Yeah, good question. So scientists have found that there isn't a limit. It's actually increasing, it's accelerating, right? So if it's going at a very different speed, so it's starting off slow and then increasing to very, very faster speeds. And like you can imagine it like let's say this this is your universe, right? What they did was they said the universe is expanding, right? But gravity is pulling the universe inside. But there is a stronger force, much more stronger than gravity, which is pushing it to expand. And this force is increasing and increasing, and it's keep on going faster. So there is no limit. It's actually just going very fast. It's increasing the speed. It's not the same speed. It's not like limited. It's just increasing. Does that make sense?
Yes, please. Thank you.
Yeah. How is dark matter discovered? Yeah. So dark matter, they just looked at the forces, right? If they just observed planets like, I don't know, exoplanets, right? They saw this planet here, and then they saw after 2 months it was here, right? Then they said, how is this planet over here if it was here at first? So then they realized that there's something pushing this planet. There's something pushing, something forcing. And that's when they realized that dark matter was causing this, and that's how it was discovered. Yeah. Does that make sense? Does that make sense? Yeah. Angel, does that make sense? Okay. Can we say that if universe is expanding, then it might create another new planet in the solar system? Um, so okay, let me just so in the universe, right? If you have this universe over here, let's say this is the universe. The planets at first they're like this, okay? But when the universe is expanding, the box becomes bigger, right? So the distance between these planets increase. There aren't any new planets forming or any new things forming, but yeah, there won't be another planet created in the solar system. It's just the distance between the planets will increase, not the planets will be created itself. Does that make sense? Rukmini, does it make sense? Yeah. And if you're like concerned about planets being created, planets can be created through like if they like what do you call die or explode or collapse, then they can be created, or like black holes can be created through that, but that's like another topic. But that's how they're created, but they aren't really created when the universe is expanding. So yeah. Any more questions, or should I move on?
I think we can move on.
Okay. Yeah. So we're going to talk about Einstein's theory. Again, Einstein was a very, very famous scientist. He had lots of theories, but the most famous theory is the theory of relativity, right? Now, Einstein, इसके पास three main laws थे, right? और ये laws है law of inertia, F equals ma, and then the action reaction law, right? And Einstein, he discovered that time ये behave करता है differently for others, right? If let's say there is a person on Earth, okay, this is a person on Earth, he's on Earth. There is another person he's sent to travel to, let's say, Jupiter, okay, Jupiter. One more person, right? He's sent from Earth to travel to Jupiter. The time for this student will be very, very fast, but the time for this student will be very slow. So based off this, Einstein discovered that time is behaving very different for these people. And that's how the law of relativity came. There is a movie on this. It's called Interstellar. If you guys have watched it, it's a good movie. It talks about relativity. It talks about how in Earth, when they go to a different planet, 10 minutes on that planet, right, equals to 10 years on Earth. So that's relativity. It's very shocking, right? It's true. That's how time behaves differently for us and for other people, right? This is what Einstein meant. Does anyone have any questions on this? You can
Madhav,
put
you
it on
can
the chat
move
box.
ahead. They can put the questions up on the chat box and we can take it all together.
Okay, yeah, sure. Yeah, that's okay. Newton's laws. Okay, like discussed earlier, there's three main laws. First is F equals ma. F equals ma is called a force equals mass times acceleration, right? Acceleration. This is a formula, okay? What this saying is the force is which is acting on the object is equals to its mass times acceleration. If there's a person here, he's pushing a ball. The force he's applying to this ball is equal to the mass of the ball multiplied by its acceleration. That's what it means. Second force, action reaction. I think that you've heard of this force. It's called for every action, there's an equal and opposite reaction. If there's a person standing on the ground, his weight, he's exerting a force here, right? The ground is exerting the same force up. This is what this law means. And law of inertia states that if an object is still or at rest, then it's going to remain at this position unless there's another force acting on it. If there's a ball, right, and it's in this position, it will stay in this position. It won't move. Okay? It will only move if you apply a force on it. Now we talk about Kepler, right? Kepler also एक scientist था. He discovered वो orbits or planets or sun or वो सब, right? He discovered Milky Way. We live in the Milky Way. It's a galaxy. He talked about जब planets revolve करते हैं around the sun, वो period, right? वो time is proportional to the size, right? If the planet, if this is the sun, okay, and this is a planet, it will take this much time to orbit. But if you have the same sun and a big planet, it will take much more slower time. So this is what he means. Well, Kepler, he helped a lot of scientists understand Earth or revolving around the sun. That's what he did. Okay, gravity, right? Yo, gravity, I think you guys have heard of gravity. It's एक force है, right? J force attracts two bodies towards each other, right? If you have a ball and you drop it to the ground, right? This force here, which is causing it to fall down, is called gravity. Okay. Now, the understanding of this force began from this scientist, or just told Newton and Einstein. ये सब scientists थे, right? And then gravity, right? Gravity over here. This helps us understand how the universe began, right? How the universe originated. It helps us with the Big Bang and CMB, like we talked about, right? This is why it's very, very important. Now we talk about quantum mechanics, right? It sounds difficult, but it's not as bad. Now, light, ये light होती है ना, ये this acts like a particle and a wave, right? This is what he means by wave particle duality. ये light wave, it acts like a wave and it acts like particle. This is what it means. Now, you cannot um if you have a planet in space, right? This is the space. This is space. You can't find the exact position. You can only find like you can't find the exact position. You can only see like how much radiation it emits, which planets is it next to. You can't find like the coordinates of it or longitude or latitude. It's very difficult to find this. This is just what quantum mechanics is. It's just this. So now when we talk about black holes, right? What is ये event horizon क्या होता है, right? ये boundary है, right? So beyond which this boundary, nothing can return once crossed. If you have a black hole, okay, this is the event horizon. If you cross this boundary, you can't come back, right? Let's say you are in a black hole, okay? This is you in a black hole. This is the opening of the black hole. If you shine a light through this hole, no light is going to come outside. This is what it means. Now, how ये कैसे form होते हैं, right? This forms from the stars. जब stars collapse होते हैं, फिर black hole they start to form. And this is just regions where gravity इतनी strong होती है, light cannot escape. This is what black holes are, right? Light cannot escape this. Now, stars, right? How can stars be formed? Nuclear fission एक process है, right? Fusion. जब gravity compress होता है और को उसमें core में compress होता है और फिर star create होता है, right? और stars evolve from supernova and beyond. Now, supernova, I remember it was a cloud, right? Stars can form through supernova. It can form through anything, right? And nebula is how stars are formed. It is like the youth or the younger version of a star. Now, yeah, Milky Way, we are हम Milky Way में हैं, एक गैलेक्सी है और हम इसमें हैं. एंड फिर तीन टाइप की गैलेक्सीज होती हैं, स्पाइरल, एलिप्टिकल और इरेगुलर, राइट. ये एलिप्टिकल गैलेक्सीज, राइट, ये um, ऐसे होती हैं, राइट, एलिप्टिकल सर्कल वाली. और स्पाइरल वंस आर लाइक दिस, ऐसे होती है. these lines, ये curvy lines, ये spiral होती है. और irregular ऐसे होती है, like ऐसे. और this is irregular. So yeah, this is irregular, this is spiral, and this is elliptical, right. जब स्टार एक्सप्लोड होते हैं under its own gravity, a black hole फिर create होता है. This is how black hole is formed. Now, in late 20th century, scientists, they began searching for ये exoplanets, right. Exoplanets बस planets होते हैं outside solar system. Or detection methods, right. They used basically, if एक universe होता है ना, और लेट्स से एक प्लैनेट इधर है और इधर है, सुपरनोवा, ये बहुत ब्राइट होते हैं, राइट. ये सुपरनोवा है. ये लाइट विच इज emitted फ्रॉम दी सुपरनोवाज, ये साइंटिस्ट इसको डिटेक्ट करते हैं और फिर दे फाइंड आउट ये प्लैनेट्स इसके साथ है. दिस इज हाउ डिटेक्शन इज फॉर, दे डू इट, राइट. And these are the planets Kepler 22b and HD. These are ये दोनों exoplanets हैं who have been detected from this method over here. Now, in the future of space, scientists अभी पढ़ रहे हैं cosmology में, और expanding dark energy, dark matter. बहुत ज़्यादा laws बन रहे हैं और principles. And yeah, so key takeaways from this PowerPoint is ये बहुत ज़्यादा laws और principles हैं, बहुत ज़्यादा scientists हैं, और yeah, dark energy एक मिस्ट्री होती है, राइट. साइंटिस्ट को डार्क एनर्जी, दे डोंट नो व्हाट इज डार्क एनर्जी, सो दे आर स्टिल स्टडीइंग करंटली टू अंडरस्टैंड डार्क एनर्जी. So yeah, thank you guys for listening. Hope you understood everything.
Yes, we
Yeah,
can get
do you have any
a
questions?
yes, we can get into the questions now. There are one or two questions on chat box. You can get started with that.
Yeah, sure. So if the distance between the planet increases, there's any effect on the planets. So if the distance increases between the planets, there isn't any effect except maybe sunlight, because if there are two planets and then if the distance, right, increases, the sunlight, right, let's say there's a sun here. Now, before, both planets are getting equal sunlight, but when the distance is increasing, maybe some planets don't get enough sunlight. So that may be an effect, but usually it's not that, like, not too much like effect. Does that answer your question? Topsy, does it answer your question?
Yes, please. Thank you.
Yeah. Can you explain Einstein's law? Was it which law was it? Like, was it the three laws, or was it the
I think she
constant?
means Einstein theory, the first one.
Which one is it? Like, oh,
Yeah,
this
yeah,
one.
this one, correct.
Okay, yeah. So Einstein came up with a constant, right? This constant, what Einstein did was he came up with, oh, okay, I get it now. So the law of relativity, okay? Relativity just says time moves different from everyone. If there's a person in outside the solar system and in Earth, time is moving very slow for this person but very fast for this person. This is the law of relativity, which is Einstein's law. Sorry, let me, there's more questions in the chat. Could humans ever travel across the Milky Way? Okay, so to travel across the Milky Way, it would take, I think, more than, I'd say, like 1 million years, because it's very big. So no, not possible now, but maybe after, like, I don't know, a few hundred years, maybe it's possible. But as of now, no, because it will take too long. What is the role of dark matter in the Milky Way? Dark matter is just pushing objects. It's just It's the force which is pushing the planets, nebulas, supernovas, all that. What causes a star to become a red giant? So a star can't be a red giant, but planets can be red giants. Stars can only transform to a black hole or a supernova or a nebula. It cannot go transform into a red giant. Now, when it comes to planets, if you're asking how they're transformed into like a red giant, this could be due to the gases, because obviously gas giants are made of gas, and maybe there are a few elements that are, I guess, red, and they like expand. That's how they're formed. Could life exist on a planet orbiting two stars? I mean, like possibly, yeah. We don't have any evidence, but yeah, definitely it could be possible. If if there's water on that planet, then yes, there could definitely be life. Can anything escape a black hole once it crosses the event horizon? So once you cross the event horizon, you can't come back. The gravity is both strong, and you will be sucked inside. You cannot come out, that you can't escape the black hole. If there's already explained by something like dark matter, or emits super massive power energy, do you mean dark matter emits a very strong force? Um, so, I mean, dark matter, what it does is it emits um, a super like strong gravitational force, not power or energy. It just emits a very strong force. That's what it does. It's just forcing stuff. It's like you cannot see it, but it forces. There is no power or energy involved. Can black hole move from one place to another? Yes, it can. A black hole can move. It is always moving. But it's like pretty slow. And in the Milky Way, there's only one black hole, but it's, I think, like a million years away from us. It will never reach us, hopefully. Um, why Earth time and space? I think that space time are different. The times are only different when you are very far away from each other, right? If you are traveling at the speed of, let's say you're traveling very, very fast, and there's a person here who's just on Earth. When you're traveling very fast, right? Your time is moving really, really slow for you, but very fast for this person. This is only the law of relativity is only if there when you're very far away from each other, and when you're traveling very fast. When you're traveling very, very, very fast, it only applies. But as of now, no one has ever reached that speed yet, because it's impossible. Maybe in the future, but as of now, no. I heard about the Bermuda Triangle. It's quite mysterious. All I know, it's not connected to the black hole, but from what I know, the Bermuda Triangle, the reason like lots of things happen there is because of like what do you call because of like earthquakes, right? There are earthquakes in the water, I'm pretty sure, and because of that, it causes a bit of like floods, storms. That's why the Bermuda Triangle's a bit, dangerous.
Great.
Um,
We can take Kushagra's question now first.
yeah. Oh, sorry. Yeah. Kushagra. Yeah.
So my question is like uh, black matter and black holes, does they work same?
Could you say that again? You're like glitching.
Okay, okay. Does the black matter and black hole work same?
So
Is
he's
is
he's asking, is black matter and black hole the same?
No, no, no. So it's called dark matter, and dark matter is like it's a force, right? You can't see it, but black hole is an object. It's an object in space. Dark matter is just like it's invisible. It's a force that's pushing stuff. That's what it is. But a black hole is an object, so they're different.
Okay.
Does that
So
answer your question?
also, yes, please. Also, I have a question. Like, does the black hole absorb planets also? Like you said, in our galaxy also there is one black hole, but it is miles away from us. Does that absorb planets also, like stars or humans?
Yeah. So, okay, if there's, let me find space actually. Okay, so if you have like, okay, if you have a black hole, right? This is your black hole, okay? If there is a star next to this or a planet or whatever, it will absorb it and the planet will be like, it will be sucked basically. Like whatever comes across, whatever comes inside the black hole, it will be sucked. Doesn't matter if it's a planet or a sun or anything. So yes, but it's pretty dangerous because it can like just take everything and eat everything. But yeah, it can absorb anything. Like there's no restrictions or anything.
So the black hole might be larger than the planet also, as we have
Definitely, yeah.
told, or it.
If you're looking at like, even if a planet is bigger than a black hole or a star, the black hole can still swallow the planet and eat it. It's like it's just the gravity of the planet is sorry, gravity of the black hole is really like it's very strong. Doesn't matter if it's big or small planet, it will literally eat anything.
Mm,
Yeah.
I have
great.
the last question.
Yes,
Yeah,
please.
no
Uh,
worries.
yes. So, as you said, if the two stars collapse, then the black hole is created. So, if the two planets can be collapse, so it creates. I have learned that it creates red giant or a sun. So, can it create black hole also if the two planets collapse?
Yeah, if the two planets basically, right, black holes are formed when you see a star. If a star is dead, if it has no, if the light is gone, if everything's gone and it collapses, a black hole is formed. And if two stars die at the same time and they're close together, there can be like what do you call? I think two event horizons. So like two black holes combined in one. I'm pretty sure that keep going around each other. But this is very rare. I think there's one, but it's very, very far away from us. It's not even in the Milky Way.
Thank you so
Make
much.
sense?
Okay,
Yeah.
great. We
Topsy?
have one more portion coming up. So we'll wind up the questions in a minute now.
Yeah. Uh, yeah. Topsy, you
Yes.
can ask a question.
Um, yes. So I have a question.
Yeah.
Sun is a star, right?
Sun, yeah.
So why sun rise in the morning?
Um, you mean, okay, yeah. So let's say this is Earth, right? And Earth, it's rotating, right? This is the sun. Sun is the same. Sun is just staying there. The Earth is rotating. It's going around in circles, right? So if you have, let's say, this is the Earth and this is the sun. If this Earth is rotating like this, there are some parts of Earth which are dark and some parts which are light, right? So this sun is giving light to this. So this part of the Earth is fully, it's night in that part of the Earth. When this Earth is spinning, then it will be the other side, right? Then this side will become light. So that's why you see the sun like going up like this because the earth is moving. Does that make sense?
Yes, please. I have one more question.
Yeah.
Like you said that black hole like eat everything. So in like in which in what second or minute he eat?
Um, could you say what do you mean?
Like um um no, it's
Okay. Tapsi, you can put up the question on chat box once you are clear. For now,
yes.
no problem. For now, I think we can get ahead. Madhav, thank you for the explanation. Is there anything
Yeah, no
left at
worries.
your end?
Anything left? Would like which we can learn?
No, any of the portion of the PPT is left?
Oh no, that's it. That's it.
Great. So can you answer the questions on the chat box by typing it out? We'll get further with the next presentation in the meantime. Yes, there is another change maker, Shiva, with us. Shiva?
Do I stop sharing my screen?
Yes, please. You can answer the questions on the chat box though, please, Madhav.
Yeah, sure.
You can type it out.
Okay.
Yes. Hi, Shiva. Are you ready?
Yeah, I'm ready. Let me
Thank
just
you.
share my screen.
Yes, please. Thank you so much.
Um, Hello everybody. My name is Shiva Sundaram. I live in Bangalore and I'm going to start 10th grade soon. Today I'll be teaching you about coding, applied mathematics, and recent breakthroughs in that. If you can introduce yourselves in the group chat, that would also be fine. So today I wanted to explain to you what is coding, why it's important, and how you can take it to the next level in your futures itself. So, what is coding? So, coding is like instructions which you give to a computer. It's like how I talk to other people in English and other people talk together in Hindi or Tamil. We talk to computers in something called code. With code, we can make computers do all kind of things, like playing a game, we can message other people, run a website, or make apps that can help people track their steps as well. Coding is how almost all technology works nowadays. Now, why is coding important? Coding is a very powerful and useful skill. It's a field of study like culinary arts or something else that grows very fast and will be very important in the future. People are already using these to do many things. They are even creating machines that can think for themselves, like artificial intelligence. You've probably heard of robots or smart assistants. Those are made with code. It's a skill that can open many job opportunities, and anyone can learn it, no matter where you're from. So today I'll be giving you the basics of coding. I'll also be telling you about AI and automation. We'll be going over some coding examples. I'll even give you some challenges. And yeah, that's it. So in order to start coding, you need a device like a laptop, computer, or phone. You also need a platform or program where you can write the code. These come in many different forms like websites, apps. These platforms are like notebooks where you write the instructions themselves for the computer. Some popular free websites are Scratch, Replit, and code.org. These are great for beginners. There's also some apps like PyCharm and Idle and Notepad, which are also used many a times for creating large software. Python, Java, and HTML are the languages themselves. So when you write code, you're writing using different key terms. And we'll be using Python today, which uses specific key terms to help us talk to the computer themselves. It's very good for beginners and is found a lot in AI. Java is used in many big apps and softwares, and HTML is what helps make websites. Scratch is a platform which you can explore as beginners. You can find many tutorials on YouTube yourselves, but we'll be looking at the website Google Colab today, which is a little harder, but I'm pretty sure we'll be able to tackle it together. Any questions so far? Okay, let's continue. So to understand coding, you need to understand the IPO model. What does that mean? It's the input, process, and output. So first, a code takes an input from a user, which is the person who's using your code, and the code itself does something, which is the process. And when the code returns a sort of output or print statement back to the user, that would be considered the output. So, for example, input can come in many different ways, like a touch screen or a user typing a message. And a process can be what the computer itself is doing. It could be adding different values, checking conditions, or many other things. An output would be what the program gives back. It could be a sound, an image, or another text message back to the user. Um, so what are data types and variables? These are also key terms which you'll need to know for coding. A variable is like a bag. It's something where you can put items in, but unlike regular bags, this bag, which is a variable, can only hold one item. However, this item can be a word, a sentence, a number, or anything else. There are two main types of variables, which I'll explain later. Now let's look at data types. Data types are the type of data which is stored inside your variable. So let's say there's a number in your variable, then that would be an integer data type. Let's say it was a word or a sentence, then that would be of a string. Let's say it's a number with a decimal, then that would be of a float. And if it has more than one item, like more than one number, it would be a list. And if it's a true or false, then it would be a Boolean. So these are the basics you'll understand. So now we'll be looking at Google Colab itself, where we will be going into the website and I'll be teaching you some basic coding. Before that, do we have any questions? Okay, so this is Google Colab. This is a website. So once you want to start coding, you're gonna click a new section. You're gonna bring it will pop up over here, and under this you will say plus code, and you will open this small box over here, which you can then start typing your code in. But we're not looking at that right now. So our first lesson for today is what is a comment? So when you put a hashtag at the start of a line, anything you say over there, the computer will not be reading. It'll just be like looking over it as if it's nothing. This is for other people who are looking at your code to understand. I've used many comments here today so that you can understand what is going on without the computer getting confused. So that's what a comment is. It's done with the hashtag at the beginning. Now, when we want the computer to respond to us or give an output, we would be mainly using print statements like this: print, and then brackets, hi. So it's important to note that you have to spell print all lowercase. You'll have to be using round brackets, and it's fine if you use single or double quotes, but they have to be on both sides of the phrase. If you do not put a quote, the computer will get confused and think it's a variable, and it will not give you it will provide an error message instead of actually printing the hi statement. So now when we click run, what will happen is it will load. The computer is sending back a message, hi, which we told it to send. So now it's not that you have to print strings. You can also print numbers or integers. And for integers, you don't need the double quotes. So when you print this, it will say 1, 2, 3, and this is an example of printing with the integers. So now we can also print more than one item at the same time, with the use of a colon and a space. So if we want to say welcome to class 4, we would do that by first in the round brackets after print, we would be saying welcome to class, and then we would give a space with a colon, and then we would say 4. So the output would be welcome to class space 4. So that's the basics of a print statement. You can print strings using colons, numbers, and you can print more than one thing using the help of of a comma and space. Now we'll look at variables. Like I said earlier, variables are like boxes which hold a value. Uh, so these boxes can be holding integers, letters, and they can be changed all the time. So this is a variable. You can name your variable anything. I've named it var right now. So it's holding the value 4863. In the next line, I've changed it to be a string instead. There'll be no error with this because we have not asked it to print yet. And then we can move on and continue keep on changing it. We will not be facing any errors with this code because we're once we print var, it's going to be printing the latest value. It's not going to get confused with what was here before. So now when we print var, it's going to say 12. Can you guess what it will say when I put this print statement? Can someone answer? Yes, Mansi. What do you think?
Bhaiya, I just wanted to say, like, can you please repeat that previous slide again? I didn't understand from that.
Which slide? The
Previous
data
slide,
types.
not
This
the comment.
oh comment. Okay.
Yes, please.
So comments are basic statements where the computer will not be reading this. This is for other humans who are reading the code, like other coders. Like, let's say you wanted to read my code and understand what is going on. You would do this by having a comment where you would start with a hashtag and then you can type whatever you want, and then the computer will not notice what this line is because it begins with a hashtag. So we'll just immediately just pass over that line. Did you understand?
Sorry, but I am not able to understand.
Can I give it a shot?
Yeah.
Okay, so basically, Mansi, what is he trying to say is कि whenever you don't want the computer to consider something and it is just for personal reference as a rough comment that you want to add up, that is where we use hashtag in front of it before typing anything out. Are you understanding?
Yes, please. Now I understand. Thank
Hashtag is just for the computer to understand that they don't have to consider whatever we are writing ahead of the hashtag. Okay,
yes.
great.
Thank you.
No problem. Shiva, we have answers on the chat box for the question you asked.
Okay.
For the var +5.
Yes. So that's correct actually. Printing var plus 5, that would be 17. That I think you all know why, because the computer will switch the var variable with its actual value, which is 12, and then we'll add 5 to that value, which is 17, and then we'll output that, and the user will be able to see it. So can someone guess what will this third statement say? Any show of hands, or you can also type in the chat box. Yes, so you're actually really close, Sania. There will be no comma though, because the comma is just so that the computer itself knows that it's two different items. If the comma was inside the colons, then it would be considered. However, since it's not, there will be no comma. It will just be book space 12. Let's try. See, look, the first print statement, printed just the variable, which is 12. The second one, like you guys said, was 17. And the third one is, you were very close. It was book space 17, not book comma space 17. Okay, now we'll be looking at what can you name a variable. You can like give the variable many different names. It could be var, a, b, box, box 5, but there are some rules. A variable cannot have special characters like these. All of these special characters which you see are not allowed. You're the only special character you are allowed to use in a variable name is the underscore. And you could also use every number. which there is. However, variables cannot start with a underscore or a number. They have to start with a letter. It could be a capital letter or a lowercase letter. So var 1 2 4 var 43 would work as a variable name, but 43 var would not work as a variable name, and you will be getting an error message. So I have brought back our variable var, which is holding the value 12. And I want you to try and tell me. So I want you to try and tell me like, would this work without looking at the comments? Whether this statement would work on as a variable statement, or will you get an error message? Yes, that's correct. It will not work. Does anyone know why? Yes, Tapsi.
Because it has like um X.
Exclamation mark.
Yes,
Yeah.
please.
Yes, that's correct. It won't work because it has an exclamation mark. Can anyone give me another reason why it would not work?
May I?
Yes,
Because it is starting with the number.
that's correct. Variables cannot start with a number. So now let's say I change it to just box 4. Would it work now? Yes, that's correct, guys. So now that we've fixed how we can name our variables, let's try some questions. So this is variable A. Inside that, I'm putting the value 6. And this is variable B, and inside of that, I'm putting the value 5. So when I print this statement, what do you think will come as the output? Yes, Sania, Krishna. Yes, you guys are all right. It would be 11. So now we're doing the next bit. Instead of putting a number in the variable itself, we are putting a phrase, A minus B. So what this does is, this means it's taking the value from A, which is 6, and it's switching it with the variable itself. So the computer is making A 6, and it's making B 5. So the value which will go into C would be 6 and 5, 6 minus 5, which is 1. So now I have a similar thing for D. What will the value of D be? Yeah, that's correct. Sania Swapnil. Um, it will be 30. Now, E, I put E here to show that this would also work with division and another number, rather than it doesn't always have to be two variables. It can also be a variable and another number. So now it's taking the value from D, which was 30, and it's putting it here, and it's doing 30 divided by 15, which is 2. So the value in E would be 2. So now this is a bit of complex math. Can you guys try to figure out what would be the output when I put this statement in? I'll give you guys a moment. Yes, you guys are all correct. The output will be 2. So now we're almost done discussing variables. I have two variables here. They're both holding strings this time. Now, I want to tell you something. You can also add string variables with strings in them. We can also add them. The output will be hello world with a space in between. This is because it's just putting the two strings together. If I had this as by world, the output wouldn't be any different. It would just say by world. It's just putting the two words together right after each other. Let's say I switch this to say string 2 plus 1, string 1. Then it would say world by. There will be no change. Is that clear?
Yes, please.
Okay, let's move on. Now we're having another we brought back our variable var and we're converting it to 1234, and now we're using this new command. It's a command that can change the data type. Remember we talked about data types like it being a string, it can be an integer. So this converts the value into a string. So how would that work? So it'll become from 1, 2, 3, 4, which is what is currently in var. It'll become 1, 2, 3, 4. It seems the same, right? But this one is in quotes. This means that when you add it, it won't be adding the same way as a regular integer. So this plus 12 will not be, this plus 12 will be 1246, right? But this plus 12 would not be the same. Instead, you would get 1, 2, 3, 4, 1, 2, 3, 4, 1, 2 instead, because it follows the same rule as our world by, because they're now strings, so it's different. Does that make sense?
Yes, please.
Yes.
Yes, please.
So now when I say what would, can you guess what would be the output for this? This is a command that converts it into integers. We looked at a command which converts it into string. Now we're looking at a command that converts it into integers. What do you think will be the output when we say print var new? That's correct, Sania. It will be 4673. Let's try and see the output of the code. So our code from earlier, 6 plus 5, like you guys all said, was 11. And like you said, the next value is 31. And we, like I said earlier, will become world by. And like Sania said, it becomes 4,763 without the quotes. Now we're going to be taking and looking at input systems. So like I said earlier from the IPO model, right? It's important to also take the value that the user is giving it, not just give the same value that the computer is giving. We need to give, so let's say you go to a shop and the guy tells you the computer, there's a computer there and it's asking you how old are you. You need to give the computer information for it to understand. That's the input, because otherwise the code will not work without that information. So that's what this part of the code is, the input statement. So it works with an input, again, all lowercase, round brackets. It can be double quotes or single quotes, it doesn't matter. And this in the middle is, this is what you're going to tell the user, the guy who's using your code, who's come to the laptop and he's like, what do I need to do? I need to enter my age. He's going to read that statement. He's going to put his age inside. Okay, does that make sense?
Yes, please.
Okay, so now what happens when when this code is run? I am going to have to give the answer to the computer. The computer is going to ask me to enter my own age. So I'm going to put 15. And the computer is checking whether my age is older. So we'll come back to that. So right now we're just looking at the input. So this is allowing me to give information to the computer. Before, we were just getting information from the computer. I could not type anything over here. I could not write anything over here. But now I'm able to change my value to whatever I want. So now we'll go back to our to our code. We are going to look at an if statement. An if statement is a little hard, but I think we can do it. So what is an if statement? It's checking something. It's making sure a condition, this is the condition, it's making this condition is met. It means it's making sure that something is doing something. So our condition here is making sure that age is greater than or equal to 13. So our variable from earlier, age, it's making sure this variable is greater than or equal to 13. Only if this condition is met, only if age is greater than 13, greater than or equal to 13, the computer will give back the message, you can watch this movie. Otherwise, if it's not, it will say, sorry, you are too young to watch this movie. So that's what the if statement is. So it's we write an if space and then we write the condition. It can be changed. We can say if age is greater than 18. So then we'll say we'll check whether age is now greater than 18. We can, instead of saying greater than or equal to, we can change it to less than. So then it's checking whether your age is less than 18, and then only then it will let you watch the movie. But for reality purposes, we'll keep it at greater than or equal to 13. So now when we enter the value, so remember age is what we are entering. We are giving the age to the computer. So what I'm entering is I'm entering 15 and it's saying you can watch the movie. The output you can watch the movie is given. Because it's checking, it gets the age 15 and then the computer substitutes and says puts 15 instead of age. And it's like, yes, 15 is greater than 13, which means I must print the statement here. Let's say I had put 7 instead, then it would have said sorry, because 7 is not greater than or equal to 13. So it would have been sorry, you're too young to watch this movie. Now let's look at the next one. Remember I said a Boolean value when we were talking about data types? That's
Yes.
with the Yeah, that's with the true or false statement. So it's like a yes or a no. Only two options. A door can be locked or it can be unlocked. There's no other option, right? So that's when we use a Boolean. We say false or we say true. So basically, the true is the yes and the false is the no. So when we put it in an if statement, we are trying to say if door locked is equal to true, then we will say the door is locked, right? Otherwise, let's say it's not true, then we will say the door is open. Because we are checking whether the door locked variable is equal to true. If it is equal to true, then we will be opening the door. I mean, if the variable is true, then we will be printing the door is locked statement. And if it's not equal to true, then it will go to the else, because else is what happens if the first condition is not met. Does that make sense?
Yes, please.
Yes, please.
Okay. Now let's look at this one. This is a bit confusing. What do you think this code will do? Just read through it and we'll try and guess.
It is similar to the age.
Yeah, it's similar to the age, but what is Sejal, do you have a guess?
Yes, please. I think the person, whoever is going to use, they have to enter a number. If the number is greater than zero, then the answer they will get is that it is positive. If the person enters a number that is smaller than zero, maybe in minus, then they will get a response that the number is negative. Hello?
Yeah, that's correct. So what happens here is, like you said, the user has to input a value, and then the computer will check whether it's greater than 0. And if it is, it will say it is positive. If not, it will go to the next one and say, is it less than 0? And then it'll be, yes, it's negative then. And if that both of these do not work, then it will say your number is 0. So you're right, Sejal. Now I have another one. Can someone try and guess what this is?
Total square. Total square.
Oh,
It
yes.
is.
Dildar, do you want to answer?
These are the concept in your salary.
Yes, please. In this code,
Hmm.
if number is more than 90,
Are these the
mark
hackathon
is more
beats?
than 90,
Sorry,
then the grade
I
Swapnil, are
know
you
Not
that.
saying something?
Artura is also hackathon only. Art
um
salary. मला आरामशीर
are you
कर.
trying to answer?
हो.
Swapnil, are you here with us?
हो हो.
Okay, I think that was by mistake. Dildar, do you want to continue?
yes, yes, please.
Well, your voice is very slow. Yeah.
Number is more than marks is more than 90, then then it will be a show a grade more grade A, and if marks is more than 75, it will show grade B. More than 60, it will show the grade C, and more than 40, it will show D. And if the marks is less than 40 something, then the grade F means fail.
That's correct. That's spot on, actually. So, last one. It's very simple. I did this one to see whether you would get confused with strings. Does anyone have a guess? Yeah, Ashura.
If the computer asks for input, what is your favorite color? So if you put blue, then the computer will respond. Blue is a calm and peaceful color. If you put some other color other than blue, then the computer will respond. That's a nice color too.
That's correct. Let's try and run the code now. So yes, so this is the first one where we had to enter our age. And this is the second one where we checked whether the door was locked. And now we are doing the one where you guys had to guess whether it was positive or negative. So now if I enter a number, let's say 6, it's going to reply to me saying it's positive. Like here, it said the number is positive because the number was greater than 0. Now, let's say, like Dildar said, if I put a number below 40, let's say I put 34, then it's going to say fail. That's correct. Now, like Ashura said, if we say any other color like red, it's going to say that's a nice color too. That's correct. So now I think we've mastered if statements, if and else statements. Now we're going to look at for loops. So if when we want a computer to keep repeating the same thing, let's say we wanted to print hello 5 times, then this is what we'll be doing if we do not have a for loop. We'll just be having this statement. We'll just be copy pasting this 5 times. But that's not how we want it to be done, right? We want to print it in a faster way without using so many lines of code. So what we do is we use a for statement. So this is a keyword for, it's in lowercase, and then you can choose any letter. I choose I usually. And then you do in, and then you choose a range. This is so that this is a little complicated. The I is going to go from your starting number inside the range. It's going to start from 0 and it's going to print all the way to the number before the final number. Okay? So how this will work is in the first loop, I is going, so what I'm doing is I'm printing I. So what will happen is in the first loop, I will start as 0. Okay? So then the number 0 will be printed. And then in the second loop, I will become 1. So now I is equal to 1. So the number that's printed is equal to 1. And like that, it'll keep on going on until the number before 6, which is 5. So it will stop here. It won't go on after, which is why we have that ending number. So let's say I wanted to print hello 5 times. What I would do is hello 6 times. What I would do is I would say hello in here, and the I will still change value, but we are not printing I anymore. The I will still change value in the computer's head, but instead it's going to be printing every time until I becomes 5. Yes, Durgeshwari, do you have a question?
Could you please repeat this part again? I'm not able to understand. The I one for
Okay, yeah. So it doesn't actually have to be I, uh, but I usually keep it as I. So what? So a for loop is it's trying to repeat. So we're trying to make a computer instead of saying print hello, print hello, print hello, print hello. We're telling the computer using a for loop. We're telling it do print for loop 5 times instead of telling instead of saying it 5 separate times. We ourselves are telling it to do it 5 times. So how does that work? Our I is there, and in the first loop, it will start at the beginning number here, 0. Okay? So we will say, so at 0, it will say 0. Then that means I have to print hello. So it will say hello. It will just say hello. So now it will go again. I will become 1. And it will do what is inside the for loop again. We'll say hello again. Like that, it's going to do it until I becomes 5. So it's going to keep on doing it. Hello, hello, hello. And then that way, we are not telling it to say hi 5 times. Instead, we are saying say hi. And then we're telling it to do it 5 times. I'll just run it once. See, look, now as you see in the bottom, the I is being said 6 times because we started with 0 and ended at 6. Let's say we wanted it 5 times. We would start with 1 and we would end. So now it start 1, 2, 3, 4, 5. 5 hellos. So now that's one way to do it. But what if you only wanted it, if you already knew how many times you wanted to do it? Let's say you were already thinking, oh, I want to say it 6 times. Then instead of having the starting and ending number, which will be a bit confusing, you can just say, I want it 5 times. And then you can say print hello 5 times. So we are not using the starting number. We're not doing 1 comma 5, or no, we're not doing 0 comma 5. Instead, we are doing just 5. So now the computer will be like, oh, I have to print it 5 times, and it will give hello 5 times. 1, 2, 3, 4, 5. Okay. Now, the next code is similar. We have our starting number, we have the ending number, but we have a new value as well. What is this? Can anyone guess what this -1 means? It's probably really hard. This is because this is a step. It's telling instead of going 5, 6, 7, 8, 9, 10, like it would usually do, we're telling it to go -1. We're telling the 5 to go every time instead of going +1. We're telling it to go -1. We're telling it to go 5, 4, 3, 2, 1 until it hits 0. Okay. So let's say I do not have this and instead I put 10. That means it'll go regularly. It will start with 5. It will go 5, 6, 7, 8, 9. It will not do 10 because it stops before 10. But we wanted to go downwards, right? So it will go with this variable, I mean with this input extra parameter, it will now go -1 every time. Does that make sense?
Yes, please.
Yes, please.
Okay. So now this, do you think this is confusing? So every time the computer goes down 1, this statement will also be printed. So that means when it's 5, when it starts with 5, the computer will say game starts in 5 because seconds will be at 5. Okay? And then in the next loop, it will go -1. So now it will be at 4. So then the computer will print game starts in 4. And then like that will go to 3, game starts in 3. Like that will become 2, game starts in 2. And then it'll become 1, game starts in 1. But it won't do 0 because remember, it always stops before that last number. So it will, and then so also you see this gap between um, the statements. This gap shows that this line is part of the for loop. That means, let's say this line is not part of this for loop. It's outside the for loop. So that means whenever we start this for loop, this go will not be printed 5 times. Only the game starts in will be printed 5 times because this part is not part of the for loop. Let's say I want it to be part of the for loop, I will have this gap here. Okay. So now in order to have a for loop, what we need to do is we need a for statement, and then we need a variable. The variable can be a single letter, it can be a longer word, and then you need an in statement, and then you need the range variable, and then you'll put round brackets. First the starting number, and then the comma, and then the ending number, and then the step. And then we always end with a colon because it's, so what does a colon do? It shows the computer, it's basically telling the computer, oh, this is the end of this line. From now on, everything which you see with the gap inside is part of this. So it's telling the like that this colon is how the computer knows I don't need to do this 5 times, but I need to do the stuff with the gap in it 5 times. Does that make sense?
Yes, please.
Has everyone
Okay.
understood so far?
Can you please repeat this one again?
Yes, please.
Okay, great. Shiva, we need to wind up now. We are way past the time. So we can do the rest of the portion later. But
Okay.
if you can take a pause, like finish this portion and then we can wind up. I
Okay,
think
yeah.
it's done, right?
Yeah, it's done with this. I did have one more other slide.
Okay. That we can do later. We can
Yeah,
just finish this portion. Is this portion done?
yeah, this is done.
Okay, great. Any questions, any doubts, guys?
No, please.
Yes, Danish.
Am I audible?
Yeah.
Yeah, so I just wanted to tell you one thing. In the starting, the first slide that you have showed, over there, it was written idle for Java. But idle is also used for Python, like PyCharm, and idle is for Python, and Java is used, we use NetBeans. I wanted to share it with you.
Okay. Yeah, that's true. The idle can be used for many things. I did use it for Java, so I was under the impression that you could use it only for Java. Thank you for telling me.
So, thank you.
Thank you so much. Krishna Rajveer.
Yes, Vyas. So my question was in that code where you have coded grades. In that, I didn't understand last one. Grade print else print grade F fail. What is the condition for that? I means when we will fail. I didn't understand.
So that means, let's say all of these other conditions fail. This
Yeah.
condition fails, this condition fails. If all of these conditions fail, it will say
But
grade is equal to F.
it is not defined for failing. Like 40, if marks is less than 40, so or equal to 40, it means grade D. But what if it's 39, then it will fail.
Yes, it will be a fail according to this program.
Okay, thank you.
You're welcome.
Any other questions? I hope everyone understood everything. Yes, please give a thumbs up if everyone understood everything so far. Thank you so much. Okay. Sakshi, what about you? Did you understand?
Yes, please.
Okay, thank you. Great. Thank you, Shamna and Fatima. Thank you. Okay, great. So I think we can wind up here. We will do the rest of the portion later.
Okay.
But thank you so much for staying back and listening and even answering. So thank you so much. Thank you, Shiva.
You're welcome.
Thank you.
Thank you so much, everyone. Bye-bye. We'll meet later.
Thank you.
Thank you.
Thank
so
you.
much.
Bye.
So much.